Hello, welcome to the ground station architecture overview video. This video is just going to be going over the current state of the microcart ground station, um, as well as some ideas for the future. My team, our time on this project is drawing to a close. It is Monday of dead week, and so we're going to be presenting on Thursday, so we won't really have the chance to implement any changes that I suggest, but it's ideas for future teams. Take it as you will, ignore it, that's completely fine. But yeah, this is how things overall currently work as best as I understand it. So, in terms of the current architecture, the way it works is there is a front end and there's a back end. This back end is consisting of multiple programs, while the front end consists of basically a bunch of functions that can call commands and send packets over the TCP connection to the back end. The front end has two types of clients. It has the GUI and it has the command line interface. And the command line interface has access to a lot of commands, while the GUI basically just has like certain commands. This is connected to the backend. The backend main program is kind of it interfaces everything together. It lets the front end talk to the custom quadcopter or to the Crazyflie adapter. It takes the VRPN OptiTrack tracker system and gives the XYZ roll pitch yaw to the custom quadcopter so that it knows where it is, or maybe to the Crazyflie if that works. And then the other thing that it does is I've kind of mentioned, it talks to these, either the quadcopter or the adapter. And the key there is that custom quadcopter is treated basically exactly the same as the Crazyflie adapter. And the Crazyflie adapter just translates the packets that would normally just work with the custom quadcopter into something Crazyflie understands. So Crazyflie uses the Crazy Radio and the CRTP protocol in order to send set points or get logging data. Um, and the Crazyflie adapter is intended to translate those things. And I have comments about that later to discuss how effective that is. Then there's the Crazyflie ground station that basically does a little bit more actual interfacing with the Crazyflie. And it is better at managing its connection to the Crazy Radio. It manages the connection to the Crazyflie test stand for MP4, and all of that jazz. So now let's start digging into some of these individual components, and we'll come back to this a little later. But before that, actually, what is the long-term vision of what this ground station could become? The idea is basically that we would have this architecture that we've described, but that we'd also have adapters or ways to connect to a custom quadcopter. So for instance, my year, SDMA 23, we have designed this FlyPi quadcopter, where the intention is that it will be a Raspberry Pi, or maybe one day like an FPGA-based small form factor quadcopter, and we could send commands to that. Right now it's all Crazyflie firmware based, so the end goal would be a TCP connection to that quadcopter, but that's not, we haven't gotten that far yet. Currently there's just a Crazyflie strapped on top of it, so yeah, that's for future teams. But the intention is that there would be a quadcopter that you could have connected there. Then also the old custom microcart quadcopter, the Zybo based ones, can be directly talked to, like we've talked about before. And maybe we can make an adapter for a Cybot and talk to it over PuTTY. That was an idea that previous teams have had. And it'd be pretty cool if anyone actually got around to it. So, um, and I think before we go any further, it's also really useful to understand why is it this way. The reason that a lot of the architecture is the way that it is so that it can talk with the custom quadcopter, the Zybo-based quadcopter that I've talked about, which was developed between 2015 and 2019. And so if you look at the quad folder on the Git repo for Microcart, it is extremely well developed. It is awesome, super well documented. That's because there is like four senior design teams back to back, just continually developing that thing. Really cool. And one of the things that one of those teams did was they made this directed graph-based calculations. And so basically, the idea is, say you have like a Simulink diagram where there's a bunch of blocks feeding into each other. Um, it'd be really useful for like a control algorithm. You could have things be rearrangeable. You could have different nodes connected to each other, outputting different things. And so that structure is kind of what informed a lot of the vernacular of the back end and the front end and the different commands that you can have. Um, and so I think that that's really important to understand. Um, and so like these graphs have connections between nodes. And there's commands in the front end that say get output, output override, get nodes. They're referencing this graph control structure. And so like get output would get you would get the output of a particular node of your graph. And maybe that's like get the output of the attitude rate PID for yaw, um, and stuff like that. And so that's good to know. Um, and get nodes, you could get like different parts of that graph control structure. Um, and then the other thing is there's the word tracker is used a lot. That refers to the OptiTrack like camera system external positioning tracker that it would know where the drone is, and that if it's the tracker, that makes the drone the trackable. And so you'll see the word trackable and tracker used a lot in the architecture, and that is why. And so that tracker information from the OptiTrack, it can't be given directly to the drone, so it's given through the back end to the drone. Um, and yeah, then the other thing is because the you connect to the drone using a TCP connection, and then it just makes a lot of sense that other stuff is connected over TCP connections too. And I think that the reason for that is that it lets things be tested independently. Like you can run the backend just by itself, or you can run the command line interface just by itself, or you can run the GUI just by itself, or the drone just by itself. And it just lets you have like a lot of modularity. And I think that's why the overall architecture is the way that it is. And so then we've talked about some of the different words. Let's talk about all of them. And so in the front end, there's a series of commands that is all the things that you can tell the back end to do. And you can tell it to get nodes, you can tell it to set nodes, you can get a source, you can set a source. And sources are basically just different values in each node. Like I said, a trackable is a individual quadcopter. In the back end, you'll actually send commands directly to a trackable, is what it seems like. Like I said, the tracker is the XYZ roll pitch yaw position given from the external positioning tracker system. Um, and output override is a command that you can give through the command line interface, or I guess the front end in general, that you can manually set the thrust, roll pitch, and yaw, either in rate or attitude mode. And so for MP4, like the 488 lab that we do, that's almost like all of the gamepad commands. And so I think output override was made so that you could have like a gamepad control versus a XYZ positioning system, because it overrides the output of the each node leading into the attitude rates and positions. And then log files. Basically, as information is logged on the drone, it will build these log files. And so like the XYZ roll pitch yaw, and their derivatives and other variables that are worth keeping track of. Log files are created continuously as the drone is going, and then the front end can ask for them, and it will receive back a file, and you can just read it and see stuff. And those files are made in a format that is specifically able to be run with the MATLAB visualization script that I think is in the controls folder in the microcart repo. And so that's pretty useful to use. 10 out of 10. I can't say that I've actually used it, but it's pretty good, apparently. So then for param, that is basically what you would think it is. You can set different values of like the graphs and nodes and things. And then outputs, that's just the output of a particular node. We've already talked about that a little bit. And so the GUI, all the GUI is really doing is just calling different front end commands. And it doesn't need to use all of them. It just uses a subset. So of the ones that I saw in there, it was the microcart connect to backend, get nodes, get param, set param, get outputs, um, and track. And basically, I think a lot of the interfacing of this happens in the Crazyflie worker class. And that I believe is to abstract away a lot of the connection to the back end with the GUI, so that that does a lot of the actual work with the back end rather and feeds the information to the GUI. The command line interface is basically just able to use all of the front end commands that are available. Um, Most data that you're going to get that's returned in like large batches, like say you want the table of contents of all the parameters or log values that you can get, like the giant list of all the things that can be logged, that would be returned to you in a log file, and you would just read it in order to see what the options are. Or the actual logging data is returned that way as well. Um, and currently, I think the easiest way to actually be able to use the command line interface is just to run the crazy cart script with a no GUI command after it. It's documented in the wiki. Took a couple minutes to do, and it was really insightful as to how this stuff actually works. And so on the wiki as well, there is this table that goes over how to use some of the different commands. You can also use the help function in order to see what other options there are for this stuff. And it was it's pretty well documented. It's relatively easy to use. So yeah, now for the back end. The back end is pretty large. I would say relatively intimidating. And until recently, not very well documented at all. I added a couple comments. Hopefully, it makes you a little bit less confused than I was, though I imagine you're still going to be confused. So, here's a couple answers, hopefully. Backend.c basically does the managing of all those connections to front end clients, the VRPN, OptiTrack system, quad adapters, custom quads. That all happens in backend.c. All those connections are TCP connections, so you can think of most of them basically as all being the same. And it translates the front end commands, which is a client basically to it, into packets that are then sent to the drone TCP connection, be that an adapter or the actual drone. The custom quad can just accept those packets exactly as they come, and then it will have callback functions in its firmware in order to do with them as it needs. But the Crazyflies use a different protocol, which necessitates the Crazyflie adapter and Crazyflie Groundstation, which we've already talked a little bit about. But yeah, that's basically what the backend does. However, it's kind of hard to find what you need in there. There's a lot of encoding of packets. There's a lot of managing the VRPN connection, and it gets very into the weeds very quickly. But this is the main structure of how it works. 90% of the actual backend stuff is just in this loop here. So there's a main function, and this is all in that, and then this just calls the rest of the functions in the backend. And so the first thing that happens is it starts up the connection to the OptiTrack system, and then it starts up the connection to the actual quadcopter. Um, and then it looks for connections to front end clients, and then it asks should it send a command to a quad, and then if it should, it will, but it gets that command from the front end. And then if it receives data from the quad, what should it do? Um, it handles all that in a quad receive function. This loop continues forever until the program decides to exit. And then when it's done, it just closes its connections. Now, the thing that happens asynchronously here is the tracker updates. Basically, as new information from that comes in, it will route it to the quad in a separate callback function. Um, and so a lot of complexity in the back end happens there. And Jones has actually suggested to us that if this were to change, one of the big things he's just changing is to get rid of the tracker callback and slot that into this main control loop here, because it would remove a lot of the complexity. So, suggestions for the future. Now, the Crazy Fly adapter, what this does, as we've hinted, is that it decodes packets from the back end, or it sends data back to the back end. It accepts normal commands from the back end and the front end that are translated using callback functions in the Crazy Fly adapter. So basically, whenever it receives a command, it will call a function that knows how to interpret it. The only ones that are actually implemented in the adapter is setParam, getParam, output override, get log file, and log block command. But here's where I start to have big issues with the way that this is implemented. Due to the nature of the Crazy Fly and how different it truly is from our custom quad, most of these callback functions do relatively little actual translating, and this is basically entirely left up to the Crazy Fly ground station. It appears that the adapter basically just lets things pass almost right through to the Crazy Fly ground station without really doing much of anything. Um, and so just cut out the middleman. That's my suggestion. Combine those two things. Now I have more suggestions, but that's one of them. Now the Crazy Fly ground station. Now that you're through all the interlocking channels, you're in the Crazy Fly ground station. How does that work? Well, the Crazy Fly ground station has a bunch of threads that do a bunch of different stuff. So the first thing that happens is it initializes all those threads, and now it has these four threads. One of them, this UI thread, is what actually accepts commands from the backend, and then it enqueues them to a command queue. That command queue is shared to this other thread, the start thread, where it will actually retrieve things from that command queue, and then it will ping the Crazy Fly and log data and do things of that sort. The other thing that the Crazy Fly ground station does is it reads the serial data from the test stand, and it will return it to the ground station as though it was just another logged parameter from the Crazy Fly. Why? I don't know. That's just the way that it is. I think it should be different. I think that the test stand should probably be connected to the backend itself because that's what manages all these connections. But this is the way that a previous team decided to implement this. The other thing in another thread here is display data. Basically, it'll just take any data that the Crazy Fly gives it and it'll print it all out to the terminal. And it gives you a lot of information, and that's pretty cool. And so now to dig into a little bit more of the weeds of the Crazy Fly ground station itself, user input.cpp is structured extremely similarly to backend.c. It has a loop similar to the one that we showed the diagram of, and it's almost identical to the one in backend.c. And it treats the connection to the adapter as a front-end client, as though, again, this were the backend. And it decodes messages and classifies them as commands using decode packet in user input.cpp. The commands from the backend, like I said, are enqueued to the commands queue, and most of them are decoded in the parse received user command in the c crazyfly commands.cpp. The fact that commands are parsed in one thread and sent in another is also a pretty major architectural difference between Crazy Fly Ground Station and the main backend .c. So I'm not exactly sure why we did multi-threading here. Um, then the commands are sent to the Crazy Fly over the Crazy Radio. But I don't believe that that was the original intention of the senior design team that made Crazy Fly Ground Station. I believe that they were originally intending to rewrite all the firmware on the Crazy Fly so that it could just connect over a TCP connection, just like our custom quad, and that Crazy Fly Ground Station would have then been managing a TCP connection to that quad and also the adapter. But I think that they got overwhelmed in the weeds of the technical complexity in changing all that stuff, which is understandable considering that there's this entire open source system that is meant to be used one way and they were trying to be using it another. Um, and then they, at that point, they already had a lot of the Crazy Fly Ground Station made. And then they decided to just write code to interface with the Crazy Radio and all of that stuff themselves rather than using the open source software that exists for interfacing with the Crazy Fly if they weren't going to be changing the firmware in major ways of CFlib. The other problem is that CFlib is all Python based and Crazy Fly Ground Station is all C++ based. So I think that's another reason that they tried to translate this all. CFlib um, was not used in the making of Crazy Fly Ground Station. This team decided to completely rewrite it and implement it themselves. Hence the making of C Crazy Radio. I mean, it's pretty successful. It works relatively well. But CFlib is open source, supported by a large community, and has forums where you can ask questions about how different things work. And so it's unclear exactly why they didn't just use that. But that's where the current state of it is. So now, I have explained some of the different problems that I have with this architecture. And now, the other thing you need to know is that we've experienced a lot of problems with actually using the GUI and stuff specifically for MP4. The thing will just crash all the time. Maybe it won't start up correctly. Occasionally, the drone will have like a 1 times E to the 27th power or something. Um, and you'll just be left scratching your head as to why this is happening. And my team went into MP4 and I just saw it still not working despite us doing a couple things to fix it, like making the set params from JSON button in the GUI and it automatically connecting to the backend, and a couple things like that to try and make things work better. But there were still bugs all over the place. And I was just like, I think I can just make something simpler and better. And so this entire project was just born out of frustration with the current architecture. Um, and it is a entirely Python, PyQt based GUI. Um, and it connects to a Crazy Fly, and that's really the only thing it's intended to do. Um, it is the front end and the back end just made simpler, hopefully. Um, and the guiding principle of it was to just use CFlib as much as possible in order to interface with the Crazy Fly specifically. Um, and so many uses of the drone and drone data are abstracted into just a set point handler and a Crazy Fly proto connection, which handles the connection with CFlib and the drone. And it's very similar to the Crazy Fly worker class in the current GUI for microcart. And so it should be able to be slotted into the microcart infrastructure relatively easily by making a mirror class of Crazy Fly proto connection that calls front end functions instead. And so the intention, I'll skip here a little bit. This is the architecture. We have the GUI, which manages a connection with a gamepad. And that GUI has these connections to Crazy Fly proto connection. Crazy Fly proto connection is what manages the connection with the drone, and it does it all through CFlib, which is Crazy Fly's Python library. And the intention is that basically right but here between crazyflie proto connection and cflib, you could make something similar to crazyflie proto connection that rather than connecting directly to cflib, you would just slot in the entire microcart infrastructure right there. And then if you had crazyflie proto connection calling front end functions, then this GUI would be able to also control the other drones as well. And it wouldn't be that hard of a change to make. Um, but basically, the major advantage of this is that it's able to be run easily on Windows or Mac, and it offers extreme speed boosts over the VM. Talking with Jones, he's not exactly sure why our VM is so slow. Maybe we're only running it on one thread, maybe or one core of our PC, and maybe by running it on more, it would be faster, or maybe that's just the way it is. But by being able to run on Windows, that can just make it super fast. Because when you run this software in a VM, it literally runs like 100 times slower. And so that's the problem the current GUI has. And it's like one of the most annoying things with it is that whenever anything crashes, you have to start the whole thing up again. Um, and it takes a long time to do that, and it crashes all the time. So the goal of this is that you would enable students to like do MP4 and complain less about the GUI and complain more about not being able to tune their PID correctly, which is the whole point of the lab. Um, and so it also, because it uses CFlib, it enables you to have a lot more confidence about the connection to the drone. It's also written in the exact same language and framework as CF client. And so if there's any tabs or functions we want from CF client, we can literally copy paste them into the project in order to use them. Like a good example would be the Lighthouse tab. If you wanted to be able to configure a Lighthouse for MP4, you could literally copy paste it into the PiCRCart GUI without changing almost anything, and it would just work, or it'd be pretty close to working, and you'd maybe have to do a little bit. But for instance, right now, the entire gamepad management tab has been almost entirely copy pasted from CF Client. I might have had to change like 2 lines. And so because of that, we can use a lot more of the stuff that Crazyfly has made with the Crazyfly stuff and with our own stuff because Crazyfly is awesome and we should do stuff similar to how they do it. Um, then once slotted into the microcart structure, you would be able to use it as like a diagnosis tool for determining whether a problem exists in the back end, the front end, quadcopter itself, because you could either connect directly using CFlib or you could connect using the microcart stuff and you could figure out where the problems are using that. And so that would be pretty cool. And again, this is how the architecture of it works. The GUI talks to the Crazyfly proto connection, and it either does this through the set point handler or it talks to the Crazyfly proto connection directly. Set point handler basically exists because it helps with some timing stuff, but it doesn't really need to exist. It could be entirely all within Crazyfly proto connection. And then in CFlib, almost nothing has changed except for one thing. We made a custom microcart commander class because the set points that we send to Crazyflies are not technically allowed. And we had to change the firmware in order to actually be able to use them. And so the set complete attitude, like the yaw pitch roll, setting attitude for all of them, that is not a command that Crazyfly normally allows. They normally do pitch, roll, and yaw rate and thrust. And so we made a custom set point type of pitch, roll, and yaw all in one. And so you need to use this custom commander in order to actually send that set point successfully to the Crazyfly. The other one is all of their rates. Normally you can't control them all outright, and it just sends a custom set point that does. Also our mixed attitude rate, where it's you can set roll and pitch directly, but yaw rate is set. Normally, actually, you would just be able to use the send set point uh, function that Crazyfly has, but it looks like last year's team, when changing the firmware on the Crazyfly, made their own custom one for it. And so I just went with that when making Microcart Commander. Um, because it seemed to work and I didn't want to mess with it. And then other than that, it just works like normal CFlib stuff. And so it just very simple. This whole thing was made in a week and a half. GUIs aren't that complicated. If you want to throw this whole thing out and do your own, that's completely fine. Just make sure it works. But on that note, throwing it out and starting over is actually something that's been done before. Trying to throw out the infrastructure of Microcart to get something simpler that works for MP4 was done by SDMA21. They had a small quad that they made themselves that they were trying to use for MP4, and they made their own ground station, and it was run in JavaScript, and it seemed pretty cool. But this was all eventually replaced with the Crazyfly and the Microcart ground station. And so, because all of this was eventually replaced, what might be more useful rather than using my thing and slotting stuff in is just to realize how to fix the actual microcart infrastructure. And so here's some suggestions I have for how to do that now. And so here's my proposed modifications. The biggest change is I think that the Crazyfly ground station and the Crazyfly adapter should be combined, and rather than using our own custom stuff, we should just use CFlib. And so that would mean the Crazyfly ground station would be written in Python, use CFlib, and it would be basically the Crazyfly adapter. This would enable it to be way simpler, and it would also enable it to that when the FlyPy is actually a TCP connection, but still using Crazyfly firmware, there are examples that exist of how to connect to a Crazyfly using the AI deck and a TCP connection. And so we would still be able to use this to connect to that and use all the Crazyfly firmware as much as we want. And it would be very simple. This whole ground station, this Crazyfly ground station, would actually be way simpler than what exists there right now. And it would probably not take that long to do. The other change is that the test stand should be connected directly to the backend, because the backend is what manages all these connections to the quadcopters, to the front end, to the drone, and to the OptiTrack system. And so it should be treated almost like a tracker. That's the other change to make. And in terms of the GUI, one of the nice things that the PikerCart GUI lets you do is you can scan for available Crazyflies and connect and disconnect and reconnect without restarting the whole thing. The GUI should be able to have that. Maybe you can slot the PikerCart GUI into there if you want. By no means do you have to, but these are the proposed modifications I would make. I think that this would fix a lot of bugs. I think it would make it simpler, and it would eliminate the complexity of the Crazyfly adapter when it's not really being used even. Plus, the more sockets you have, the more places that things can just get lost. And so, yeah, that's the proposal. In terms of what the Crazyfly ground station architecture would pretty much look like, basically it would just be this command loop. Basically, it would just be this command loop. It would translate commands to Crazyfly talk, and then it would send those commands to the Crazyfly using CFlib directly. And then whenever logs are updated, it would update the, or whenever the parameters are changed, it would update the param table of contents log file, and it could just feed that directly back to the backend without having to send a bunch of packets to the Crazyfly itself, because CFlib actually manages all the parameters really easily. And then you could also just configure the logs as requested from the backend. And then in parallel, you would have a logging callback that you would configure from CFlib. And as that callback happens, you would just add to the log file using the same format as before. And you would pass it back to the backend whenever asked for it. This would be relatively simple. And I think it would work better than what we have right now. So yeah, that's it. That's how the ground station architecture works. That's the changes that I think should be made to it in the future. Do with that what you will. Thank you very much, and I hope that you have a good day.